we're going to prove De Morgan's law. So the proof that we're going to have is for any sets like A and B, the complement of the union is the intersection of the complements. We're going to try to prove this. Very good. So proof, as usual, to show that two sets are equal to each other, you need to show that left-hand side is a subset of right-hand side and right-hand side is a subset of left-hand side. Prove the equality between these two sets. We need to show that first, A union B complement is included in A complement intersection B complement. So this is your number one. And also you need to show that the complement of the intersection of the complements is included in the complement of the union. Number two. Okay, very good. We're going to use translation, going back and forth between the definition. So by definition, and some properties that we learned, we're going to prove the very first one. So again, put a question mark. So to make sure that you're trying to prove each one of them separately. The very first one says, hey, for any random element X in the complement of the union, that element must land in the set on the right-hand side. It means that you're trying to show this for any X belongs to A union B complement. You're going to try to show that X belongs to the intersection of their complements, question mark. How do I prove this? Very good. So let us take a look at this. It says X belongs to the complement. So by definition, X is not in the union. X is not in this union. Well, what's the meaning of that? It means that it is false. Guys, remember the definition of union. It is false that X is in A or X is in B. It is false that. Well, so remember that by the logic, it means that X is not in A, and let me use a different color. This color doesn't work. Throw it away. And X is not in B. So it is false that X is in A or X is in B. That's the meaning of this little thing that you wrote down here. X doesn't belong to A union B. In logic, converting the set into the definition, it is false that X is in A or X is in B. But this is equivalent to X is not A, X is not B. But remember that it's false that. So you're going to distribute the negation over the parentheses. Well, so in set language, what's the meaning of that? X is in a complement and X belongs to B complement. So we just showed that X belongs to A complement, intersection B complement. What we try to prove. Very good. So I just proved number one. We're done with number one. I took a random element in the left-hand side and showed that that element belongs to the right-hand side. So very good. Now the second one. By definition, we're going to prove number two. Again, take a random element like X and show that that X belongs to this set here. So for any X belongs to intersection of the complements, you want to show that, put a question mark, that X belongs to the complement of the union. Okay, very good. Step by step. What do we have here? It says, hey, X belongs to the intersection of two sets. So X belongs to the complement of set A and X belongs to the complement of set B. All right. But what's the definition here? X is not in A, X is not a member of B. That's the meaning of that, all right? So what's the translation here? X is not in A and X is not in B. So let's write it in English. X is not in A and X is not in B. Very good. So let us use the De Morgan's laws and rewrite this. So it is false that X is in A or X is in B. All right, excellent. But what's the translation here? X is not in A intersection union B. We're using the or. So X is not in this set. It means that X belongs to the complement of the union. Which what we try to prove here. So we're done with the second one as well. So what is our conclusion? Our conclusion is, since we showed that these two sets are subsets of each other, it means that they are equal as well. Since we proved that these sets are subsets, so they are equal to each other. Subsets of each other. So they are equal. Okay, we're done with the proof for De Morgan's laws.